Okay, I want to look at a polynomial problem. I'm going to give this problem to you to do for homework, and it will have several parts to it, and I want you to do every part, okay? The polynomial that I want you to evaluate and find the roots for and do a plot of and so on is p of z equal to z cubed plus z squared plus z plus 1. Okay? Now, if you remember, I said in class that any odd order polynomial, where the highest power of the polynomial is an odd number, any odd order polynomial will have at least one real root. So this polynomial has at least one real root, and I want you to figure out what a real root of the polynomial is. So part 1 is going to be to guess a real root. Okay, it's not hard. I'm not going to give you any more clues. You should be able to do it. Guess a real root. Now, once you guess that real root, let's say the real root is c. So guess a real root. Let's say it's c. Then I want you to do division to find a second order polynomial. So I want you to take this polynomial p of z, and I want you to do division x minus c, so that's one root of the polynomial, and divide that into the z cubed plus z squared plus z plus 1. And when you do that, that should give you some second order polynomial. Second order. When you find that second order polynomial, then you have to do the third part of the problem, which is complete the square to find the other two roots. Now those roots may be a complex conjugate pair, remember? So I want you to find the three roots of the polynomial. Begin by guessing the real root, do synthetic division to reduce it to a second order polynomial, complete the square in the second order polynomial to find the two remaining roots. Something else I want you to do is plot the absolute value of the polynomial. So I want you to plot magnitude p of z. Okay. And so from that plot, you should also be able to see the root. So I've done that plot here on my grapher. Let me show you what it looks like right here. You see here, these are two roots right here. Here's another root over here in this corner, right there. Okay, this is the real axis right along here. So you see there's a real root. Here's the IY axis. So you see there are some imaginary roots. So you need to find the roots of that polynomial. Now, I don't want to hear that your grapher can't handle the complex numbers, because if it can't, what you need to do is you need to put in x plus iy for z. So you need to make that substitution. So here's what I'm saying is you need to say z equals x plus iy, and you need to take that and plug that in for each value of z and p of z. And when you do that, you need to expand out z cubed, z squared, z, and so on. And doing that, you'll get the real part of p of z, and you'll get an imaginary part of p of z. And just to shorten, I'll write that as RP for real part and IP for imaginary part. Okay, so that'll take, and you have to do a little algebraic manipulation to find those two. And then you can determine what the magnitude of P of Z is by doing the square root of the real part squared plus the imaginary part squared. Okay? So you'll find these as a function, you'll find this as a function of x and y. Each of these will be a function of x and y. In fact, let me write that here. The real part's going to be a function of x and y, and the imaginary part's going to be a function of x and y. So you'll need a grapher that can do 3D graphs, and you'll be plotting the values of these. You'll determine the values of the real part and the imaginary part as a function of x and y, and then you need to plot this, and this will be a function of x and y. So you're going to be plotting magnitude P as a function of x and y. Now, don't tell me that you don't have a grapher that can do this, that you don't have a 3D grapher. You need to find a grapher, get a grapher, and do it. Okay? I don't want excuses as to why you didn't do it. And so you need to think about it and get this problem solved. Okay? Thank you. See you next time.